Hey, from room 224 studios in the heart of the G-Wing, I am Mr. Klein, and I am here to host the Unit Review Show. This is your unit review packet. It is on Canvas. You should print it out. In fact, if you haven't printed it out, pause the video, go print it out. And then let's begin. The year was 2019. No one had even heard of COVID-19. And a select band of students from my class went to go take the AP exam. On the AP exam, questions are always worth 9 points. Up here, I'm going to give you a little information about how America did. So in this year, the mean student in America got a little more than 2.5 of those 9 points on this question. The standard deviation, don't worry about that. It's a measure of how spread out things are. All right, so that's a side note. I just wanted to give you a sense of the difficulty of the question. Here's what we're going to do. You and I, we're going to do the first 2 problems on this review today. And on the first one, you can cross off A. We don't know how to do that yet. So we're going to do B, C, and D. I'm going to be quiet. I would like you to pause the video, read the problem stem, and then attempt part B. Okay, and ladies and gentlemen, check your work. Here's what your 3 trapezoids should look like. I got those using the data that are in the table up here. To do one quick example, the change in t on the first interval is 0.3, and these represent the heights of the trapezoids. So that's why I got 1/2 0.3 times 0 plus 55. This one, drawing the picture, is a little hard because the negatives make it look weird. You have funky trapezoids like this. Okay, answer should come out to be 40.75. If you got that, give yourself a little bit of a pat on the back, and then take a shot at part C. You want to pause the video again now. Okay, and let's check our work. What you should have done is graphed this new particle called VQ, and then also graph the speed or the velocity of 60, and you'll see that there's 2 places where they intersect right here. Boom and boom. Using the intersect feature, I found that those are at 1.866 seconds and 3.519 seconds. This asks us the distance traveled. And recall that distance traveled is the integral on the interval of the speed, or the absolute value of velocity. When you put that into your calculator, you get 106.1 meters. Okay, there's your answer. Now, question. Could you have also just removed the absolute value? Do they have to be there? The answer is that in this case, no, you don't need them, because see that the velocity is always positive. So the distance traveled and the displacement are actually the same on this little interval because our velocity is always above 0. Okay, let's do D together. D is a little goofy. D says at time t equals 0, particle Q is at a position of -90. Using the results from part B and the function v of q from part C, approximate the distance between particles P and Q at time 2.8. So this one is a different question. You'll notice that here we were asked for the distance traveled, and that's when you want to use the absolute value. This right here is asking us for the distance between 2 objects. And in order to find the distance between 2 objects, you need to find the position of both. right? If you know that that Perry is standing at 5 and Queenie is standing at 7, then the distance between them is 5 minus 7. Absolute value is 2. Okay, so here we go. Let's find the position of P first. So I'm going to say P of 2.8 represents P's position. Now, we need a start and we need a change. And we were given at the very beginning of the problem that particle P is at the origin at time 0. So that's a way of telling us that his start is at 0 plus his change will be the integral from 0 to 2.8 of his velocity. Oh, we found that right here. So it's 40.75. The position of Q is, they tell us that at time 0, he starts at -90. That's given to you in part B, plus the integral from 0 to 2.8 of this equation right here. So I put that into my calculator, and the number that I come up with is 45.94. Therefore, the distance between is the absolute value of subtract these two numbers. Okay, and that's going to give us, what is that? 5.19 meters. And we're done with problem number 1. Let's go on to problem number 2. Also from the 2019 exam, this is funsies. And the mean was a little bit better. Mean on this one was a 3.2, standard deviation 2.1. Okay, let's see. Fish enter a lake at a rate modeled by the equation E of t is equal to. Okay. Fish leave a lake at a rate modeled by the function L given by. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. Okay. We know that this right here is a rate in, rate out problem. We always want to start those two ways. First thing that you want to do right off the bat, before you do anything else, is note that the rate of change of the fishy fish is equal to the rate at which the fish enter minus the rate at which the fish leave. So the rate of change of fishy fish is equal to this. And then we want to put those two equations into the old calculator. In, out. And the other thing that's worthwhile is if they give us an interval. Did they give us an interval yet? No, not yet. All right, so let's work through the pieces here. Pause the video, try A. Okay, let's see how you did. A asked us to find how many fish enter the lake, so we're only using the enter equation. Since it was a rate, we take the integral. The value that we end up getting is 153 fish. Okay. Pause the video and try B. Let's see how you did on B. B says, what is the average number of fish that leave the lake per hour? So it's the average rate of leaving. And we're given the rate of leaving here. So it's asking us for the average value of L of t. So what we want to do is take the integral of L of t. That'll tell us the total number of fish that leave. And then we want to divide it by 5 minus 0 for the number of hours that have gone by. When you do that, you get 6.06, and that is in fish per hour. Okay. Once again, I want to emphasize that this right here gives you the total number of the fishy fish who leave. And that's why when you divide it by the 5 hours, you get the rate. Okay. We are moving right along. I'm going to be quiet for a minute. You try C. Pause the video and then unpause when you're ready to check. Let's see how you did. So the first kind of hill to get over here is to graph the two functions. And when you graph the two functions, the rate in and the rate out, you want to make meaning out of their y values here. So what I notice is that there's this point where they intersect. And this point is at t is equal to 6.2 hours. And before 6.2, the blue curve has a larger y value than the red curve. That means the rate in is greater than the rate out, which means that the number of fishy fish is increasing. Afterwards, the fish are leaving faster than they're coming in because the y values are larger here than here. So the number of fish is decreasing. So in other words, the graph of the number of fish, which we can't actually draw because we don't know how many fish there were to start, it goes up until 6.2 and then it goes down afterwards. So obviously right here, ding, 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 at times 6.2 hours is when the maximum must occur. And so a way to describe that is like this. Here's the rate of change. And it is positive for all times less than 6.2, negative for all times after. Therefore, the global max has to occur at 6.2. Good stuff. We are in the home stretch. I'm going to be quiet for a moment, and you try D. Pause the video. When you're done, unpause, check. Let's see how you did. The problem asks you, is the rate of change increasing or decreasing? If you want to know if something is increasing or decreasing, you look at its derivative. So the derivative of the rate of change at 5 would be E prime of 5 minus L prime of 5. Now keep in mind, the reason I'm taking the derivative is because they asked us whether the rate of change is increasing or decreasing. If it had just asked us whether the number of fish is increasing or decreasing, right? Then we would just do E of 5 minus L of 5. But since it's the rate of change increasing or decreasing, we got to take the derivative. This is equal to negative 10.7, which is less than 0. So the rate of change is decreasing. All right. And that's the game, folks. There are 2 problems. I encourage you to do the other 3, and I will see you later.